My dear students, in this video I am going to solve some application problems in combination which are in your textbook. See, the problem is find the total number of subsets of a set with 4 elements. See, number of subsets of a set with 4 elements. How many number of subsets are there for a set containing 4 elements? By combination method we have to find the number of subsets. You know, empty set and the set itself are the subsets to what is that? Improper subsets, you know. The set, given set itself and an empty set. These two sets are called subsets of the given set, but which are improper subsets. And a few more proper subsets, you know. These are the topics you have studied already. So, find the total number of subsets of a set with 4 elements. So, the number of subsets with no element, that is empty set. Number of subsets with no element, that means this set is called empty set. It's also a subset. The number of subsets of a set with no element is one, you know, that is given set containing 4 elements. Therefore, we can consider that 4C 0. No element is 0. 4C 0. Okay? And the number of subsets with 1 element. Number of subsets with 1 element is 4C1. Number of subsets with 2 elements. Two element is 4C2. Number of subsets with 3 elements is 4C3. Number of subsets with 4 elements, that is the set given set itself, the whole set 4 elements is 4C4. Adding these subsets gives you the total number of subsets. Therefore, the total number of subsets are total number of subsets of a set containing 4 elements is 4C0, 4C1, 4C2, 4C3 plus 4C4. 4C0 you know 1. 4C0 is 1 element. 4C1 is 4. 4C2, 4 into 3 by 1 into 2. 2 2s are 4. Therefore you get 2 3s are 6. So 4C0 is 1, 4C1 is 4 plus 4C2. 4C2 is 6 plus 4C3 is nothing but 4C1. 4 minus 3. 4C3 is 4 minus 3, that is 1. You know already NCR is equal to NCN minus R. Therefore 4C3 is equal to 4C4 minus 3, 4C1, that is 4. And 4C4 is 1, NCN is 1. Therefore, the total elements are, so total subsets are 5 plus 5, 10 plus 6, 10, 16. So, the number of subsets of a set with 4 elements is 16. And this is expressed in our set language. You will see 1, 2 power 4 subsets. Total number of subsets with 4 elements is 2 power 4 subsets. This is an idea we have studied already. So 16, it is nothing but 2 power 4. Similarly, total number of subsets with 5 elements. If the problem is another problem, if you consider to find the total number of subsets of which the 5 element. So number of subsets with 5 no element is 5C0, C 5C0, 5C1, finally 5C5. It is 5C0. Next, number of subsets containing 1 element is 5C1. Number of subsets with a single element is 5C1. Number of subsets with 2 elements is 5C2. Number of subsets with 3 elements is 5C3. Number of subsets with 4 elements is 5C4. Number of subsets with 5 elements is 5C5. Number of subsets with 5 elements is 5C5. So the total number of subsets are adding these 5 numbers, that is 5C0, 5C0 plus 5C1 plus 5C2 plus 5C3, like that you can get 5C0 plus 5C1 plus 5C2 plus 5C3 plus 5C4 plus 5C5. 5C0 is 1, 5C1 is 5, 5C2 is 5 into 5C2, 5C1 is 5, 5C0 is 1, 5C2 is 5 into 4 by 1 into 2, 1, 2, 2 2s are, 2 2s are 4. 5 into 4 by 1 into 2, 2 2s are 4, 5 into 2 is 10. So 5C3 is nothing but 5C2, 5C5 minus 3. 5C3 is 5C5 minus 3 is 2, 5C2 is 10, and 5C4 is 5C5 minus 4, 5C1, that is 5, 5C5 is 1. Okay, 5C5 is 5C5 minus 5, that is 5C0 again. 5C5 is nothing but 5C5 minus 5, you can think that it has 5C0, which is 1, 5C or NCR equal to NC n minus R, 5C5 minus 5, 0. 5C0 is 1, So 1, 5, 5C2 is 10, 5C3 is 10, plus 5C4 is 5, and 5C5 is 1. Adding these things you get 20, 30, 32. This is nothing but 2 power 5. If the set containing 5 elements, the total number of subsets are 2 power 5. If the set containing 4 elements, the total number of subsets are 2 power 5. If the set containing 5 elements, it consists of 2 power 5. Similarly, if a set containing n elements, if the set containing n elements, total subsets are, total number of subsets are 2 power n. By generalizing 2 power n. If the set containing n elements, the total number of subsets are 2 power n. These are the ideas which you have studied in the set language. So using this combination method, we have to find out that we have finding the total number of subsets like that. The number of elements given, the subsets are 2 power the set element number of elements. Okay? See, next problem. How many different selection of 5 books? How many different selections of 5 books can be merged from 12 different books? You have 12 different books. In the 12 different books, you have to select 5 books. How many different selections of 5 books can be merged from 12 given different books? See, condition is, first condition, 2 particular books are always selected. See, out of these 12 books, 2 particular books are selected always. So, 2 particular books already selected. 2 books selected already. Because these 2 books are always selected. 2 particular books selected already. So, remaining 3 books can be selected. See, out of 5 books, you have to select 2, you have selected already 2 books. Therefore, remaining 5 minus 2, 3 books to be selected from the remaining 10 books. Because out of 12, 2 books have been selected already. So, the remaining 3 books can be selected from the remaining 10 books. Therefore, the number of 2 books have selected already, therefore the remaining remaining 3 books be selected from remaining 10 books. Remaining 10 books. So the total ways are, total selections are 10C3 only, because 2 books have been selected already. Therefore, 3 books should be selected from the 10 books. Therefore, the number of selections are 10C3. 10C3 is, 10 into 9 into 8 by 1 into 2 into 3. The procedure is 3 times to be reduced from 10 and 3 factorials can be divided. So this is 3 3s are 9, 4 2s are 8, so 4 3s are 12 into 10, 120 selections. So 2 particular books always selected, the number of selections are 120. Second case, 2 books never selected. So in this case, 2 books cannot be selected every time. Therefore, the 2 books can be eliminated from the total books. So remaining 10 books, you have to select all the 5 books in this case. Because 2 books never selected. So in this case, second case, if the 2 books never selected, in this case, the total number of selections are the 5 books can be selected out of the remaining 10 books only. So if the 2 books never selected, therefore the 5 books all the 5 books can be selected from the 10 books only. If the 2 books never selected, therefore the 5 books all the 5 books can be selected from the remaining 10 books only. The total selections are, the 5 books can be selected from 10 books only. The total selections are 10C5. The total selections are 10C5. 10C5 means, the value of 10C5 equal to 10 factorial by r factorial into n minus r factorial, n minus 5 factorial. That is equal to 10 factorial by 5 factorial into 5 factorial. 10 minus 5 is 5. So you simplifying this, you will get 252 selections. So 10 into 10 factorial is 10 into 9 into 8 etc. 1. Out of that 5 factorial can be cancelled from numerator and denominator. So 10 into 9 into 8 into 7 into 6, like that 5 times only. You reduce from 10 divided by 5 factorial, you will get 252. On simplification, you will get 252 selections for the second case. That's all about the problem. Okay? Next problem. There are 5 teachers and 20 students are there. We have to form a committee. Out of these 5 teachers and 20 students, we have to form a committee consisting of 2 teachers and 3 students. In how many ways can be selected? First case, general. 5 teachers can be, from out of 5 teachers, 2 teachers to be selected. Out of 20 students, 3 students is to be selected. That's why the required selections. First, out of 5 students, 2 teachers, the required collection or selection. The required selections are out of 5 teachers, 2 students. Out of 20 students, 3 students. That's all. The required selections are out of 5 teachers, 2 teachers to be selected, and out of 20 students, 3 students to be selected. This is the general idea, general way, first selection. So 5C2, 10. And 20C3 is simplified, these 2, you will get 11,400. 11,400. 20C3 is 20 into 19 into 18 by 3 factorial 123. 5C2 is 10. Multiplying will get 11,400. And first case, next one is general total idea, total consideration from 5 teachers to 2 teachers, 5C2. From 20 students to 3 students, 20C3 and in combination, you will get multiplying these two, you will get 11,400. In the first case, a particular teacher is included. Particular teacher definitely included. Therefore, the remaining 1 teacher can be selected from the remaining 4 teachers. Okay. A particular teacher is included. Therefore, another 1 teacher can be selected from the remaining 4 teachers. A particular, in this case, a particular teacher is included. So, the total ways are out of 4 teachers, 1 teacher should be selected because 1 teacher is already selected. Particular teacher is already selected, therefore remaining out of 4 teachers, you have to select another 1 teacher only because 2 teachers you have to select. And the students out of 20, you have to select 3 students as usual. That's all about this case. In this case, 4,560. On simplification, you will get 4,560. Second, a particular student is excluded. A particular student is excluded. That means eliminated. 1 student is excluded from the 20. A particular student is excluded. But out of 5 teachers, 2 teachers to be selected. 5 teachers, 2 teachers to be selected as usual. But the students, out of 20, 1 student should be excluded. Therefore, the remaining 19 students, you have to select the 3 students. This is the method. Out of 20 students, a student should be excluded. Therefore, total 19 students only you have. From that, you have to select 3 students. In this case, 9,690 selections. After simplification, you will get. See, that's all about the problem. See, I have solved so far 3 different problems and few more problems we have solved in our next video. See, these application problems are very much important for both state board and CBSE students. You should follow these carefully and we will continue in our next video. Thank you.